So problem 7.1 asks us to prove that an eigenvector mu, specifically the eigenvector mu corresponding to the second eigenvalue in the first direction is equal to that of the third direction, and both of those are also equal to 0. So we start out with our value for the eigenvector, or eigenvalue, rather, lambda 2, which in this example is equal to 5. So taking the matrix for tensor f that the example gives us, we can turn each row essentially in that matrix into one equation. So we end up with the three equations you see here. We then plug in our eigenvalue, in this case being 5, for lambda in each of those three equations. And then we can start to solve for the different eigenvectors. So we look at 2. Just naturally, I looked at 2 first, since this was the shortest. But unfortunately, it doesn't give us much because we're trying to find the mu1 and mu3 values, and all we're given there is that mu2 equals 0, so that's no good for us. So we move back to equation 1. I see here that mu2 disappears, it's just being multiplied by 0. So I decided to solve for mu1 in this case, find out that it's just equal to mu3. So we now have a value we can substitute into equation 3. So doing that, we find that mu3 is also equal to 0. And since from equation 1 we found that mu1 is equal to mu3, then we get our proof that mu1 is equal to mu3, and both of those are equal to 0.